So this is a function question, slightly different notation. I've rewritten it in terms of a function of x and g of x. Okay, so f of x and g of x are two different functions of x. This notation up here just means the same thing, okay? So a composite function is we perform f first and then perform g on the result, okay? So we're looking for g of f of x. So we work out what f of x is. What's the rule for f of x? Well, that is the rule. And then we're going to put that rule into g, okay? So we're going to replace x, so there and there, we're going to replace that x with that expression f of x. So x becomes 2x squared plus 1, and then x becomes 2x squared plus 1, and then we're just simplifying that for the rest of the question. For part B, the inverse function is like the reverse function. Now, we did this one way using a function machine, but because we've got an x value here and here, it's going to be really hard to use a function machine. So what I'm going to do is just make g of x y, and I'm going to rearrange this whole equation so I end up with x equals something to do with y instead of how I started, which is y equals something to do with x. So the first thing I did was I multiplied both sides by x minus 1 to get rid of that. Then I expanded this bracket, okay? Then I took away 2x from both sides. So I took away 2x from both sides, and I also added y to both sides, okay? Because I wanted everything with an x on the left and everything else on the right. Then I factorized out x, okay? Because the idea is you want to get x equals, so you're going to need to isolate the x. So I factorized out an x, got y minus 2, and then I divided both sides by y minus 2. Okay, that is a very tricky question, definitely a grade 8 or 9 question. And then to represent it as an inverse function, I just changed the y's for x's. So it's basically the reverse rule, okay? The reverse of the original function g of x.